And let's see. Which one's the share screen?
Whoa! Echo, 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 echo.
The green arrow? Okay. Oh, sorry. I didn't mute it. My mic's muted, but no, it's not. Huh? Oh, there we go. All right. So did you see the green arrow? It's right about here.
Can we turn the lights down a little bit?
Yeah.
I'll do this. Ooh, moonlighting. I just unplugged it.
Oh, okay, cool. It was good. It's just timing was weird. Okay.
So what do I want to share?
So there's like share your whole desktop or share an application typically. Okay. It should be the green arrow should be the share button. No, it's fine.
Share.
And if it doesn't work, that's fine. We'll sacrifice those people that aren't. Just don't worry about it.
Right?
Okay. Yeah, there's a cooler to the left.
And did you get a bottle of water or something?
Yeah.
Okay, you got it. All right, we're still working through a few technical things. It's great to see a full house here. I'm Dave Medberry, but you already knew that. This is Ian
Coley?
This is Ian. Inktank, Red Hat recently acquired Inktank. I believe it's being used as a wholly owned subsidiary, so I think they're retaining some of their Inktankness.
We are for now.
We are for now. Okay, that's the last I heard. So he's based, I think, in Golden, Colorado, and he took the commute here to share with us a little bit about Ceph and what's going on with Ceph and OpenStack. In the back, we have some leftover T-shirts from the HP Meetup last month. I think there's still some back there, and there might be some stickers. If anybody can get a Red Hat sticker and wants one, we'll find you one somewhere. Let's see. Obviously, there's pizza. There's soda in the back, left of the pizza, and there's water, soda, Diet on the left, Mountain Dew on the right, Diet Dr. Pepper, Diet or Coke Zero. Let's see. Next month's meetup is not fully planned yet. Is that right?
Yep.
But we're talking about a couple of different things. It'll be sometime later in the month. We know Thanksgiving's coming, and the Paris Summit's at the beginning of the month. So somewhere in there, we'll wedge in another meetup. And we've talked about a couple of different things. We hope to hold it at Cable Labs. Is that
So I got to figure out the logistics.
Logistics? But the room that we wanted for this week was still being upgraded. So it'll be a brand new room when we get there, if and when we get there in November. At least a new projector or new speakers. And that, as you know, those of you who've been there, that's an awesome facility. It's not located right next to Canara or anything, but it is still an awesome facility. So look for details on that later this month. I am going to ask Ian to take another drink of water, and then I'll ask him to actually introduce himself because he could do a much better introduction than I can. I do believe he's a vice president at Red Hat, but that's about as far as I can go.
It's showing my shirts, but it's not showing my presentation mode, even though it's presentation
mode. Okay. Well, that's okay. They'll have your words.
Okay.
Presumably, your mic's on. Yep. That'll be good enough. And I'm going to take this back to my seat.
Okay. All right, I apologize for people listening online because I tend to wander when I talk. I'm a former assistant professor at a community college, so that's part of my teaching style, to make sure that people aren't falling asleep. Heads down in pizza. Or the kids I had, it was trying to hide their phone and text. friends in the other classes while I was asking hard questions. My name is Ian Coley. I am the, well, it's some fancy name, Global Director of Software Engineering. But the only reason that sounds so fancy is because that basically means I have everybody that works on Ceph at Red Hat, formerly Inktank, works for me. And so they threw the little global thing in there because I've got people from Crimea. So yeah, a guy that used to live in Ukraine now lives in Russia. He didn't move. Country borders moved. And guys in China, Lisbon, Atlanta, even far off Minnesota. So we have a team that's spread off, completely globally distributed. Now we do have an office in LA. The reason we have an office in LA is because that's where Sage Weil, the father of Ceph, lives. So we wanted an office that he can work in. And we've got about 10 to 15 people there. The entire rest of the engineering team is totally globally dispersed. So we do everything virtually via Hangouts. We use a new Red Hat thing called Blue Jeans, because Google is proprietary code. And if you're a true open source zealot, you should avoid it at all costs. Says the guy using his Gmail account to sign in. Said sometime in his recent presentations, he's a little bit embarrassed to say he's been working on Ceph for 10 years, but it really has been.
And the part he was starting to work on isn't done yet.
We'll get to that. That is the ironic part, is this started out as a file system project at UC Santa Cruz, Lawrence Livermore, you know, scary secret nuclear testing stuff in there. They wanted a file system that could compete with Lustre, and so they gave him some grant money to go off and work on Ceph. Well, here we are 10 years later, and the file system still isn't done. So that's, I'll get that out of the way. We'll come to that later. But people typically hit me up, well, when's the file system going to be done? I can't promise anything, but stay tuned maybe next year. But of course, I've given that same speech for the last 2 years that I've been with Inktank, maybe next year. So what things really took off was in 2010. Sage was able to get Ceph into the Linux kernel, and then in 2012, actually started a company. He tried to run this out of his own little skunk works at DreamHost, which was his web hosting company that he built up while he was in college outside LA. And finally decided, you know, we need to stand up a real company that only does this, and this can't just be this little backroom thing that I'm doing as an offshoot of my web hosting company. So started Inktank, and see we've got our fancy new logo down here that says Inktank by Red Hat. And that's because as of, we haven't updated, well, it was officially, I think, April 30th, so I guess that's right. But my first day as a Red Hat employee was May 1st, so we were acquired on April 30th by Red Hat. Basically brought everybody over from Inktank, including Sage and crew, and we have been operating essentially as an independent unit within Red Hat. We're getting slowly integrated into the various organizations. That affects more the business, salesy type guys. Me within engineering, they pretty much leave us alone. Other than those of you who got stickers, I'll apologize in advance. Had they told me they were going to just send you Red Hat propaganda, I would have brought true Ceph stickers. I thought they were sending Ceph stickers. And so, unfortunately, the only thing that says Ceph on there also has a Gluster thing on there, which we're brothers now, we're all friends, but really it's, you know, if any of you have brothers, you know how it is with brothers, okay? There's a little bit of a friendly rivalry there, and that's good. That's good. And that's one of the questions that we get a lot at Red Hat is, wait a minute, you had Gluster, why'd you buy Ceph? Well, they also had XFS and ButterFS in the kernel. Is anybody complaining about that? Or ext4. Why is it a problem to have competing technologies? Personally, as an engineer, I think it's great. I hope we, you know, beat each other up and make each other stronger, and whoever has the best answer for a use case, you know, more power to them. Now, the sales guys, that's a problem for them. I'm in engineering. I don't have to deal with that. I just want us to make the best code possible. So, why are you guys here, and why should you care about Ceph if you're interested in OpenStack? This is, after all, this isn't a storage meetup. This is an OpenStack meetup. Why should you care about Ceph? Well, because it'll be interesting to see what the next survey results that come out in Paris are. But as of the one in Atlanta, there's Ceph. if you're using storage for an OpenStack system, other than just standard LVM, you're most likely to use Ceph in your implementation. We do have a little bit of our new Gluster brethrens down there. But as you see, wow, where EMC is, where whatever sans/HP, I'm not sure. And we've got HP 3 par, so we've got a little bit of HP represented. But look at how tiny that is. Why is that? Let me take a guess. If you're involved in this OpenStack environment and you're pushing free, cheap, commodity, you're not going to want to also dial up your EMC guy and say, hey, here's a ton of money for storage that I'm going to run OpenStack on top of. And that's why it fits nicely with Ceph, and we'll go more into the architecture principles. But Ceph was built, architected from the ground up to be run on commodity hardware. So we can then argue about what commodity means. Is that HP, Dell, guy down the street, you know? But by what Sage meant when he originally architected it around commodity hardware is expect stuff to break. Don't pay for the top-end guy that's going to guarantee you 6 nines availability because he's got all the smarts built into the RAID chassis. But expect the underlying hardware to break on you all the time, and you, in software, build in the reliability to hide that from the end user as much as possible. So again, here's the comparison between the two models. The old model is, okay, you buy everything proprietary. I've got my nice little box. It's in a rack. I'm not really sure what's in there. It's some secret sauce that I'm paying a lot for, and I've got a subscription contract for that I'm locked in for. And basically, I'm not really sure what's going on inside. That's the other part that really bugged Sage, is he is adamant about open source. He loves the fact that if you're not sure what's going on, if you see a problem, you should be able to dig down into the code and find out what's going on there. There's no attempt to hide anything. There's no attempt to lock people into anything. You can run this software on any hardware. You pick. I mean, it's kind of an overused term, but the democratization of storage. The idea was you can pick your hardware. If you're an HP shop, go buy HP. If you're a Dell shop, go buy Dell. Heck, if you're an EMC shop, go buy EMC. But you can run our software on any of that. So what is the architecture of Ceph? We're gonna build upon by starting at the bottom here. I'll give you a second to read the acronyms, but it's built upon an object store. So when we talk about Ceph, sometimes people can mean many different things. Some people might mean the gateway. A lot of time in OpenStack land, they mean the block device, and then there's the file system. But Ceph comprises all of these. It's an object store at its heart, and then each of these components are built upon that. So let's start by looking at the object store. What is Rados? Well, each of these equates to a physical device. So if you look at, we recommend running an object storage daemon, which is, there weren't enough OSD acronyms out there. Most people say object storage device, but we decided to try to rename that acronym. And that sits on your standard Linux file system. Which one you use? That's up to you. Right now, we're leaning towards XFS. Some people have ext4. Btrfs. Btrfs has some issues. It's got some really good features. We'd love to see it a little more stable. And there are even some people using ZFS. So again, that's the whole idea behind this is you pick and choose what works best for you. Out of the box, we tend to recommend XFS, but if you find a use case or if you want to use one of these other ones, more power to you. And then that runs on whatever disk you want. These could be different sizes. You could have 2 terabyte drive here, and a 4 terabyte drive there, and a 1 terabyte drive there. And Ceph is smart enough to figure out how to spread your data across it. And we'll go more into the specifics of that. So when you see this little icon here with the green with the little red under it, that's representing one of these OSDs, an object storage daemon, which is the daemon on top of a Linux file system on top of a drive. So if you want to equate one of these boxes to a drive, you can. And then we have the M's, which stand for monitor. Go into them a little bit more in this slide. So you've got your whole cluster here. For some of you astute math people, you may notice quickly that there are an odd number of those M's. That's because these are the monitors which are exchanging system health information via Paxos algorithm. Now what that does is by having an odd number, you avoid a split brain. So you can't have 2 people say, I vote for this, and 2 guys say, I think the system, the cluster status is this, and go, oh, what do we do? You always have an odd number. Now, you probably don't want 1. That's not much of a vote. So most clusters have 3, and if you get a really large cluster, you'll have 5, like this example here. But typically,
you can get away with 1 if you're doing a proof of concept set at your desk. That's where you
fine.
can.
Yeah, if you're building something in your home,
Yeah.
go for it. But otherwise, you do 3.
When you talk about clusters, is it typically like close by, like within an availability zone, or is it geographically distributed?
It's up to you.
Latency issues there.
What we tend to recommend is you want to have your monitors dispersed, just because, if something goes wrong, you want to be able to ensure that you've at least got, you probably would want to put all 3 of your monitors in the same rack, and the whole rest of your
So you do
100
one on the
petabyte
East Coast,
system.
one on the West Coast, and the latency between them wouldn't be an issue.
We don't recommend doing that. We actually recommend standing up different geographically dispersed clusters.
Okay, so a cluster is like.
Yeah, this would be
Like
a
within
single
the data
geographic
center.
unit. Yep, the data center. So let you read that. So again, the M is the monitor, and so what the monitor does is it say, hey everybody, here's what I have as far as system health. I think these OSDs are out there and alive. Does everybody agree with me? And then it pushes that map around. Now it also gets updates from each of the OSDs. The OSDs talk to each other as well. So they talk to the other OSDs that are close by them physically, and they talk to OSDs that they're logically related to. And we'll get a little bit into the mapping of data, so they know I am the guy that holds a copy of this other guy's data, so I should probably know if he's up or not. Because if he goes down and he's gone, I need to start moving some stuff around to make sure that I maintain my replication. Because the core of Ceph is built upon replication. And that's what ensures that you don't have to be dependent upon your storage device to save your data. Because we recommend 3 copies typically. In the examples I use here, it's just 2 just for ease of use and simpler charts. But typically 3 copies of all your data. So we've got the original and 2 copies that are floating around in your data center to ensure that if something happens to one of them, you still have access to your data. So here's a question. There's kind of a couple different ways that if you're an application trying to find an object, you can do it. This is the kind of standard old school metadata server. Hey, can somebody tell me where this is? I go look up in the metadata server and it says, oh yeah, you want this blob? That blob's over here. And I go, oh, thank you. And then I go back down the trail and go and find my data. Now, if you're a little bit sharper, maybe you do some sharding. You say, okay, I'm going to run this algorithm, and it's going to tell me that, oh, if I'm looking for F, F is always here in the A to G range. That's great. That's really good, except for when this zone changes. So right here, let's say I've put in that I've sharded this to these 8 drives. But what happens if 2 of them go away? And that's where this told me to go. Well, hopefully you're doing maybe you're doing something on the back end and you're moving stuff around, but typically this causes a lot of problems if there's any data outage, or especially if you add data, just a typical sharding. So that's where Sage came up with Crush. It's another fun algorithm. Controlled replication using scalable hashing. And so what Crush does is you give it a Crush map, which allows you to say, here's my layout of my data center. I've got these racks on these bus rows, and I want to have one copy of my data on SSDs that are in this pool. I want to have 2 copies on SATA drives that are maybe a couple racks over, and it takes all that information, and based upon that, it crunches algorithmically where to chop up your data and stick it. And that starts with a concept called placement groups. What we do is chop up that object into a number of PGs, and then feed that into Crush, and then Crush tells us where to put each of those PGs based upon the rules that you set via your Crush map. And that can change if you have bus row go out, you're moving an entire new rack in, you update your Crush map. And then the monitor takes that and pushes it out into the OSDs. So now in this case, see, we've got our object, got chopped up into PGs, and then it calculates using the Crush map that you gave it. Okay, where do my green bits go? Well, I've got the original will go here, and just let's say my rules are this is one bus row and this is another, and I'm telling it I want one copy on each bus row because I don't want to have to worry about my power going out and taking out both my copies and losing everything. So based upon that rule, it says, okay, I'm going to take this green chunk and put one over here on this drive, and its copy I'm going to make sure is over here, that it's nowhere in this group.
Is there a concept of a master and a backup?
There is. The concept is the primary and the copies. And the reason we allow you to do that is your reads always go to the primary. Because at the base of this, as we saw back with our OSDs, this is creating Linux files. And so those are, if you're doing a read, and there's a possibility you're going to read it later, it might still be in cache on that primary device. So instead of having you read it from any of the copies, where then it'd possibly be a little colder, so it speeds up your reads.
So the output of Crush then is an OSD.
The output of Crush is
Some number.
is an OSD map. So it maps your entire system into OSDs.
The other thing you mentioned earlier is that primary could be on an SSD, and that might be for performance. So you might have all your primaries on SSDs, not the same SSD, but on SSDs, and have your secondaries be on lower tier storage.
Does it move?
We'll see. We'll get into some examples of movement. So here's my example. We take your object, we hash it through Crush algorithm, puts one original there, one copy there. Okay. So now we're just expanding that example to show the entire object shot across these PGs. I duplicate that slide. Well, so how does it know where to read? This is the big part. The client has the Crush map, and it does the same calculation. It doesn't look up in any table where to find it. It does the same calculation using the Crush map and say, oh, I'm gonna read this green bit. It's gonna be here. Or if this guy's not here, it's gonna be here. But what happens when we lose the device? How does Crush handle that? So in this case, we've got the red and yellow primary bits here. And they disappeared. Well, these guys, I was talking about before, you're always talking to the OSDs that you're serving copies of, as well as your neighbors. And so they say, hey, I haven't heard from this guy in a while. Something's going wrong here. and they'll talk to the monitor. They'll say, hey, monitor, I haven't heard from this guy. And then the monitors will do their Paxos vote, and they'll say, yep, we haven't heard from him. Let's mark him down. So it's down. And the duration of those timeouts and everything is fully configurable by you. So you can, if you have, like, maybe you know that your drives tend to flap, and so you don't want to necessarily mark it down, and you're okay with it maybe being up and down a little bit, then you can configure it so that it won't be marked out of the cluster immediately. Maybe you'll be a little more graceful and wait for it to come back. Or you could be extremely stringent and say, no, anytime you see that guy down, if 2 different OSDs say he's down, mark him out. I'll come have somebody deal with it later. So what happens? And this is the cool part. So independent to you, the admin, you, the user, whoever, Ceph starts moving stuff around. You don't have to do anything. It detects that this guy's down. The monitors push a new map out saying, hey, based upon the crush rules that we have, and knowing that this guy's gone, we've got to replicate that data again. So how do we do that? And it starts copying the data. Again, totally independent of any operator intervention. It does it.
So it needs to tell if the client's sending crush map too, right?
Yep.
There's like an epic on every crush map that gets updated. That's the first thing you check.
Yep. So here's the client. Now he knows, okay, based upon my updated map, now I know I'm going to my read. Okay, I wanted the red block. The primary was here. Now I've got to move down to this other block. My primary yellow was over here. I've got an updated map. Now I know if I want to read, it's down here.
The client has to know about every single disk, basically, whether it's up or down. It's part of the question.
It doesn't know that. It just gets told by the monitor, here's your updated thing. If you're looking for data, here's what you want to use.
It's computational on the crush map. The crush map will just spit out a different address. It doesn't know anything. It's like it's similar to the hash value changing with every epic. And so you just rehash what you're looking for, and you just end up getting a different address. It's not memorization. So it's like a single fact that changes. It's actually a set of maps.
So what happens when you, like, the data hasn't moved yet, but the crush map is telling you that it's at this new location already?
It won't tell you that.
It'll tell you when the backups.
Yep. You'll be pointing to a backup until the primary is replicated. Well, here's a happier scenario. So what happens when you add more drives? You update your crush map. All of a sudden, you turn these guys on. Oh, that didn't. Wow. I guess we call that a storm. Let me get my screen. So what happens is that basically it replicates using the updated crush map and pushes stuff around. Now, what you can do is you can throttle this so you don't get, oh my God, there's this bandwidth storm because you rolled in a new rack of storage and it's doing all this replication and everything, and you can't serve I/O to existing clients or anything. So you can set a priority to where it'll do this in the background, and so it's migrating data around slowly while you continue to serve reads and take writes up here. And it looks a lot better. So again, all this that we're talking about, though, this is just the base underlying object store that everything's built upon.
And when you said the client, is there the concept of a Ceph client, or are you talking about a literal data consumer, or are you talking about
There's a Ceph client.
Are you talking about, when you say client, though, are you talking about a piece of hardware that you own that sits between the person asking for it and the storage?
There is no piece of hardware.
That's software. Just software.
Well,
It's in the kernel.
That's what I mean.
No,
there's something separate from the storage.
There's a user space and a kernel client. So it's a piece of code that is doing all this and going out and talking to the storage. So
And so far, you've really just been talking about the raw Rados objects, not anything that's built out of the Rados objects.
So this is how we start building stuff out of those objects. at its core level is Liberatos, which is a library which then has straight socket connections into that cluster. And that library has bindings. Pick your favorite language: Python, C++, heck, even Erlang. I haven't played with that, but you know, if you're into Erlang, you can. This allows you, like, if you're some high speed, I think the term we're allowed to use rather than giving names is a web scale company. You can guess whoever that might be. If you were doing that, then you could write your own applications, because you don't want to mess with anything else. You don't want to mess with RBD. You don't want to mess with RGW. You don't want to mess with anything that we've built on top of it. You want screaming on the socket as fast as you can give me bits of storage. Okay, that's what you want. So you're going straight to the library. You don't mess with anything else. So that takes away all the other overhead. You can write your own programs calling right into this library, which plugs right into the object storage. So that's where we see a lot of the higher speed customers doing their own very detailed, specific to their application programming. So again, we're just sitting right here. So what this allowed us to do then, as Inktank and now Red Hat, is we built applications on top of Liberatos. Just so happens that the first two applications we built on here were RGW and RBD.
How big is a Rados object?
You can set that. And 4K to 4 meg to RBD, we typically recommend 4 meg. But we have anywhere from 4K to 128K to 4 meg. It's configurable. That's one thing. If there's one, I'll say, frequent criticism of Ceph, is that there are so many knobs that, because Sage really wanted it to be, you can do whatever you want to do, that you can hang yourself. Because there you can, oh, maybe I didn't realize I set it to 4K writes and I wanted 4 meg writes. So that's why people that are getting started, we really encourage you to look at the documentation, get an IRC, ask for help. The community is very supportive, and all that's free. I mean, that's not me talking as a Red Hat guy trying to get support. I'm saying, just as a community member of Ceph, the community is very, very strong, self-supportive. People are always in IRC. I mean, we as Red Hatters are in there all day, but you have people from Europe and Asia that are in there. So the pound Ceph on IRC is manned 24/7.
And that's on OFTC, typically not Freenode. So
Yep.
if you're looking for it, look on OFTC IRC.
And if you wind up in Freenode, I try to point people back gently, saying, and the banner, even on Freenode, says, this is not the real Ceph channel. Go to OFTC. There's still people that sit in there. So, read. So again, what we did then is we took and we said, okay, we've got Liberatos, we've got the object store, what do we want to put on top of it? And we said a lot of people seem to like these gateways. Amazon's not doing too bad with S3. So we wanted to build something that is S3 and Swift compliant. So that's the interesting part about the Rados gateway, is we're kind of bilingual. We don't care if somebody's coming from an S3 implementation or a Swift OpenStack implementation. We satisfy a subset of all those APIs. Now, the specifics of your use cases where you need to be sure to work with us or the community to make sure that if you've got some special Gucci portion of the API that you really need to have, make sure that we satisfy that, because we're not 100% compliant with the S3 API or the Swift API. Part of the Swift API challenge is that they only rev it every 3 or 4 years. Some people are on V2, most people are on V1. A lot of the Swift functionality isn't really in the API. It's buried in Swift itself. So it's hard to satisfy what people really want. Sometimes people think they want something from Swift, and it's being exposed via underlying Swift storage system, not necessarily via the API. So we're pushing the Swift community to put more of their functionality truly in the API layer so that we can ensure that we're compliant with it as the gateway. So what Rados Gateway does is it takes those calls, okay, standard Swifty calls and translates those into, using librettos, into object storage calls. So you've got the same underlying reliability that we talked about with the object storage, where you're using Crush to manage your moving data around where you don't have to worry about any underlying reliability. That's all managed for you. And then you have the front-facing portion that is handling, serving out those HTTP requests.
So if you use the Swift API that Ceph provides, how does it handle the authentication? You get it.
We'll get to that. Yeah, we're integrated with Keystone. Okay. More goodness words about RGW. So the next one, and again, what most OpenStack people are interested in is the block device. So I assume most people know what a block device is, but what is frequently used for, especially in OpenStack environment, is spinning up VMs. And the reason it's so powerful with spinning up VMs with Ceph is we're not tied to the hypervisor. Okay? You can have your VM image stored over here, and then however you're serving it, maybe you want to move the actual compute node from one rack to another. We don't care. We'll keep your storage right here. So it allows you that flexibility within your system. And we'll get into some of the specifics that are especially, I think, attractive in RBD. This goes, there's a kernel client as well as the user space client. But the images are striped across the cluster. So you're not tied to a specific location. You've got that striped functionality across the entire Rails cluster. You've got that built-in redundancy. And you've got integration with, pick your favorite hypervisor. Again, we try to be as open and integrating with as many different things as possible. Look at like even Nebula. I know after some of the consolidation announcements this week, people are wondering how long some of these to the right of OpenStack are still going to be around, but you know, we'll try to support it if we can. One of the significant things up here I want to talk about is copy on write close. Does anybody know what that means? Go ahead. What is copy on write clone?
It means you get a zero cost to copy instantly, and that there's only any cost when you actually do the write the first time.
Right. So here's a scenario. Let's say I have an image of a web server, and I want to spin up hundreds of them. Boom. I spin up 100 copies of that. Zero additional storage.
And it's
almost
zero
one
additional
minute.
time.
All at the additional same time. Until I do my first write that is different. The original.
But we spin that up, isn't it? And every single web server reading off of that one primary disk. Yeah.
That disk, though, is already striped across.
Remember that we're not talking about one single disk, one physical disk. So what this allows you to do is you spin them up, 100 copies. There's no additional storage. Then when there's a write, well, let's say I wrote 1 meg of that 1 terabyte web server. Okay, well now I've taken up 1 terabyte for the original and 1 meg for the copy, because that's the delta. Snapshots. Snapshots are really interesting because one thing that we haven't implemented yet, it's on a roadmap I'll get to later, but is true like RBD disaster recovery. So one of the ways we've got around that is with snapshots. And what snapshots allow you to do is say, I want to take a snapshot of this block device image, and I want to send it across the wire to someplace else. And then I can copy it. Well, the incremental snapshots are where the real power is. So it's like doing your differential backup every night, if you will. So I'm taking just a delta snap. So maybe I had 4 megs in that 1 terabyte image change, and then maybe I had 4 gigs, and maybe I had 25 megs, and you can just ship those snapshots of snapshots and snapshots across the wire. You're not consistently sending that whole terabyte image across.
Can you do these snapshots online?
Is it integrated with Cinder?
It is, but I'll go into some of the integration issues and some of the expanded stuff we're looking for in future OpenStack releases. And let's remember, we're building up Rados and using Librados, the first two applications we wrote were the gateway and block device. Now, everybody's favorite thing to beat me up on, the file system. Let's go back in time 10 years ago. Why did Sage get money from Lawrence Livermore Labs as a starting grad student to go off and work on this? It's because they wanted a file system that could compete with Lustre in high-performance computing. 10 years later, we're still not there. Lustre is, I used to work at Intel on Lustre, and it's a hell of a piece of software. These are not easy problems. There's a reason that not many people write distributed file systems. There's GPFS, Lustre. That's about all I can think of. And hopefully someday, soon there'll be CephFS. So what is CephFS? It's kind of, if you think about it, your standard doing your lookup, which I earlier told you you don't like to do at the object level. But when you're talking about files, you kind of got to do it. So you're doing you've got these metadata servers. That's what this little icon is. So you're sending the metadata to the metadata server. The actual data itself is then getting extracted across the underlying Rados system, just like RGW did, just like RBD did. So you have that underlying protection of the data using Crush. So what do you expect out of a file system? I mean, the usual owners, timestamps, all that stuff, quotas. Now, one of the exciting things for me about the Red Hat acquisition was Red Hat really means it when they preach open source. We had created as Inktank this Calamari tool, which is kind of the standard startup-y thing is we're going to sell you free open source software, but hey, would you like some support in this nice Gucci proprietary tool? So the first thing, I mean, like this was non-negotiable from day one. They said, you guys need to figure out how open source is as soon as we buy you. And we did it within 3 weeks. That means getting through all the lawyers and going through all the commits and everything and getting permission from everybody. And this was open source. What Calamari is a front-end management monitoring tool into your cluster to allow you to see how is your Ceph storage cluster performing. So you can see here you got a cute little usage dial, your IOPS, what is the status of your cluster. Here you can see the number of OSDs and mods. That's a little bit unrealistic. We have 5 monitors for 35 OSDs, unless you really want to have some overkill. And then just some cute charts you can look at for trending. This is just one thing. Management is still coming down the line. Yeah, I mean, it's architected to be both monitoring and management, but right now it's one. And so this is all built upon a salt structure. So you've got minions down here on each of the OSDs and the mons talking to the Calamari master node. And that's the architecture of everything Ceph-wise. Calamari has really become its own open source project. When we open source it, it's because it's entirely separate from Ceph. So it's got its own user community and everything. We kind of talk about it because we helped birth it, but in reality, it is its own separate open source community. It's got its own section of our GitHub. It's got its own contributor list. It's got its own email list. And if anybody is good at PHP or JavaScript and wants to contribute, I'm sure they'd appreciate your help. Yeah.
You leave this section. FS says not finished yet. It's not cluster, but it works, functional.
Well, it does. It does. The thing, kind of our, when Sage and I talk about it with the team, our MVP, minimum viable product, we feel like we have to have some way for you to scrub your data. Right now, we could have hidden errors in there and data corruption, and you would have no way to know. I'm not comfortable saying, even in a community hat, that, you know, let alone a Red Hat supported thing, that, oh, sure, go ahead and use this. I mean, there are people running CephFS on production systems around the world right now that are having no problems that they know of. That's the problem with silent data corruption. You don't know about it until you hit it. And you could go 2 years and not hit it, or you could go 3 days and hit it. And that's the problem with data corruption.
There are some guidelines for using it if you want to try and use it. Something like a single metadata cluster, a single primary metadata with maybe spare and reserve in case the primary goes away.
Exactly.
And that will mean that you have less opportunity for that corruption to happen.
Yeah,
And
we
there are,
definitely.
I know there are people using it in production or OpenStack specifically to solve some OpenStack specific problems, so you don't have to have an extra kind of storage around.
We run it in-house at Inktank. We dog food it. We run our in-house testing lab on it. And it's pretty stable. The problem is, until we can do that true, what we call forward scrub, backward scrub, to where you can scrub through the metadata, match it up with the actual data, and vice versa, then how can I give you any sort of a confidence level that your data is okay? Until you can run the equivalent of an FSCK on your data, I'm not comfortable saying that people should be using it in production. That's just me.
I would recommend using the Views driver instead of the kernel driver from personal experience.
Yeah. To kind of segue here, I just want to interrupt for just a second. So besides Ian, who's here for the first time that hasn't already got a frisbee? These are the 4th OpenStack anniversary frisbees paid for by the foundation. So OpenStack Foundation. Also, I'd like to give Red Hat, Inktank a big hand. This is just an opportunity to recognize you, and thank you for coming so much. If you've got any questions about the meetup or anything, feel free to find me afterwards. I don't have any deadline tonight, so I'm happy to talk to anybody afterwards for as long as you want. Now I'll give it back to you.
And also, had I known that there was a Five Guys nearby,
Oh, man.
and knowing that this was all on my sales rep's credit card, I said, man, hook me up with the Five Guys, not some.
I couldn't figure out how a good way to get Five Guys catered up here. We could have just taken
Just met over there, you know.
We could have just taken over the building, yeah.
So now we're getting out of the basics of what Ceph is to now how do people use it. What we've been building up to this point, we started object store. Okay, what do we put on top of it? Great. How do people use it? This is one of the most common, where people write web apps that again make these S3 and Swift calls. We handle a subset of both. They call into the gateway that sits on top of Rails. We talked a little bit about geographically dispersed instances and what we recommend. Here you have a case where you got a cluster in Europe, you got a cluster in New York, and you got these two syncing up. So this isn't to where you got true, where you can make calls into each one. This is more, this app server is talking to this guy, this app server is talking to this guy, and then they've got a journal that occasionally says, hey, here are the rights, keep them in sync. That's a different process that runs.
That's part of your RTP. You do that synchronization.
Yep.
Is that the federated gateway?
So you could call it that, but it's not a true, I don't think you call it a true federated gateway because, at least in my parlance, if it was truly a federated gateway, these would stay in sync all the time, and it wouldn't matter if I wrote here or wrote there. What this is right now is you have a primary and a backup. And so this is writing primarily to here and then syncing across to here. So the picture might be a little.
You can only
The commit
read
happens
from
as
the
soon as
local.
it hits the US.
Yes, and you can only read from the local. So it's not like you can go over and I'm over here and just if this guy's hammered, I'm going to get shipped over there.
How can you monitor how far behind the backup is?
That's a great question that I don't know the answer to. Send me an email with that and I'll find out.
So is if you have a web app that's in Europe, is that hitting the US East cluster or is it it's going?
Nope.
Okay.
It's going to hit this guy. So you're going to hit your local gateway.
There's no consistency logic here. Like if you write the same thing on both sides, it's whoever wins.
Yep.
Okay.
That's one thing we're working on for future gateway improvements. And we'll get. I didn't give you much of an overview. I apologize for that, but I'm going to go through these use cases, and then we'll go kind of into future plans, stuff like that. Here's another one of our common use cases. So you've got an erasure coded backing pool. We'll go into in my next couple slides what that really means. What is erasure coding? How we implemented it. And then you've got a replicated cache pool. So everything I've talked about so far has been replication to get you your savings. I mean, to make sure that your data is there. To maintain your data integrity, I've said we recommend 3 copies. So you've got your primary and 2 other copies. Well, that's great until I go to my NetApp rep and he says, 3 times the storage you're telling me to get 4 terabytes, I have to buy 12 terabytes? I can get you that in my new E-line for this. And they can be pretty close. So that's why we got a lot of requests for erasure coding pools. So what is erasure coding? Instead of our standard replica storage where you've got 3 physical copies of the data, this is more like when you think of your standard RAID. It's happening. Here we chunk up the object. We don't give you 3 different copies of it. We give you 4 data blocks in this case. This is all configurable. Call this K plus M. So K are your bits of data that it's split into, and then 2 are your parity. So in this case, we've got an M of 2. So what I'm saying is, out of these 6 chunks, I need 4 of them to ensure that I have data integrity. So I could lose number 2, and it's fine as long as I've got X. I could even lose 1 and 2 as long as I've got 3, 4, X, and Y. That's where you get your data integrity. Now this comes at a cost. I mean, nothing's free in computer storage. In this case, when anything's going on and one of my guys goes away, then I just go and replicate him in the background, and it's not a big deal. But if say 2 of these guys go, if 3 and 4 go away, and I've got to figure out, oh man, 3 and 4 are gone. I was reading from 1, 2, 3, 4. Now I got to go over 1, 2, X, and Y. Well, that takes more compute cycles. So this is going to burn a little hotter than this. But erasure coding is going to be a lot cheaper. So instead of, say, 3 to 1, where in this case I've got my 4 terabyte drives that really I'm paying for 12 terabytes of storage, here you can do all this at about, depending on the erasure code that you use, 1.4, 1.5. So now maybe I'm buying 5 or 6 terabytes instead of 4. That's a lot easier to sell off to a CIO than 12 terabytes, especially when you're talking about cold data.
Does erasure coding calculation happen at the client? Further down.
No, it happens further down.
And how do you handle, like, on the replicated scenario, how do you handle corruption? Like, copy number 3 becomes corrupt.
We do internal verification. So if we notice that this one's not in sync with these 2, then it'll destroy it and create another copy.
So that's some background thing.
And again, you configure how often it goes through and doesn't scrub. Those can be pretty intensive, so we recommend doing those in off hours and things. And again, you configure how often you want to do it, and at what level too you want to do scrubbing.
Erasure was released in Firefly?
It was.
Okay. Giant's out, right?
RC is out.
Okay.
The real giant should be out in a couple weeks, hopefully.
It's not going to be supported by Inktank Enterprise until H. Is that correct?
Right. We kind of do this every other thing. So far, I mean, we're not tied into that. It's not dogma, but so far we want to keep the community development going. And so we've stuck to this every 3 or 4 months. The community will crank out a new release. But as Red Hat and Inktank, we want to ensure more stability. The 3 to 4 month cadence ensures we get lots of new features in there all the time, but that also kicks up a lot of dust with all that velocity and all that new code landing and all that churn. So we want to ensure that we've got plenty of time to truly QA it on the other end. And that's why we tend to, on the supported side, only pick up every release and put it to our extended QA.
Does the H octopus have a name yet?
Hammer. And I'll even give you a teaser of the eye, which is secret proprietary data not released until tonight.
Wait, question on the erasure coding. Does that work with the gateway, the RBD, and Ceph?
Ceph doesn't work with Ceph. I don't know if it works with Ceph. And I think there's a bug with RBD that we're working on, but it does work. Another mode, cache tiering. We implemented this in Firefly. So you've got your kind of standard write back cache. So this is, let's say, I want screaming data, either whether it's I'm just dumping a bunch of data or I want to read it really quick. So I want screaming here. But I don't care what's down here and how long it takes. So maybe I put some SSDs up here, I put some SATA down here, and then the cache dumps. The writes go into that, and then it slowly migrates down to the backing pool. Now we've still got some performance issues that we're working through as far as cache misses. So if I go to read something that's not in the cache, and then I have to pull it up from the backing pool, that's an area of performance improvement we need to work on. Now here's another one of your common cache tiering modes. Is where, okay, I'm not going to write. This is like your write once, read many scenarios. Say on a Netflix, I'm not going to be writing out, Sherlock every night. I'll get it in my backing pool, but I know I need to pull it up when people start watching it. When I've got a new season comes out, I'm going to pull it up in the cache so that they can stream it quicker. Then we'll slowly migrate it back down. It's a little less popular. Another one of our use cases, and this is what I alluded to with the web scale companies. They're just writing stuff straight on the socket. I mean, as fast as they can go, their own proprietary app servers, writing stuff right to librettos and Paretos. And now this is the kind of the most popular area we've seen erasure coding is for cold storage. So if you got stuff for compliance reasons or something that you have to keep around forever, but God, why am I spending all this money to keep it on an expensive RAID, and maybe I don't trust tape? Buy your commodity hardware, throw it in an erasure-coded pool, stick it in a rack off in the corner, and what happens is the cache pool slowly replicates it off to this backing pool, which is erasure coding. Remember, with the erasure coding, this is only costing me 1.4 to 1.5 times. So I've halved my storage cost from site A to site B. So right here, I want to dump it to site A to keep it initially, and then I'll gradually farm it off to my backing pool, which is half the storage, and then eventually I'll probably delete it off of here, keep doing that cycle.
Is there any concern about bit rot with this cold storage model? Got it leave back there for
More than anything else.
I have the scrub going too. That's on erasure code.
Yep. Yeah, it's just like any of the other. You run that same tool that I talked about in the background to kind of go around and see, okay, instead of checking my replicas, now I'm checking my erasure coding. So are these still valid? So I've got my k plus m, are if I lost any integrity within those, doing that same type of repair. And the last, I'll call this the last, because we haven't really done a lot of performance testing around this. And so while people use this in the community, I've heard people running this in operations, we just don't know how well this performs, whether you're on MySQL, Maria, your favorite database. I definitely don't think we're going to be certified by Oracle anytime soon, especially since we're now Red Hat. But people do this. People run databases on top of the block device all the time. We just don't advertise this as a supported configuration as far as Inktank because we haven't done the performance testing to justify to ourselves that it's a good idea to do. All right, so I've gotten you this far, and this is an OpenStack meetup, and you're like, when are you going to talk about OpenStack? So, all right, now, finally, let's see. An hour into his talk, he's getting OpenStack. So here are the main components of OpenStack that we integrate with. There's a question earlier about Keystone integration. So keys are in here. Users it'll integrate straight into Rados Gateway. So you don't have to set anything up additionally inside of RG. Swift, again, with the, you don't care about the S3 side, obviously if you're an OpenStack notation. And also, in case somebody thinks of it, just because I put something in with S3 and it's now in RGW doesn't mean I can pull it out with Swift or vice versa. Two are mutually exclusive. You have an S3 pool or a Swift pool. Don't cross the streams.
Is it a single Rados Gateway instance that's actually handling those? Is it listening on both APIs? Okay.
Yep, all the time.
Do you see many people that actually use Ceph implementations with APIs or multiple layers or
Both. We have the big customer for us that uses, actually most of our customers use S3. But of the subset that use Swift, there are some that do both. And the big one, DreamHost, uses our implementation Swift.
They're your parents.
It's like your mom's on you're cute, you know. How much can you believe that? So, but they're the big one. There is kind of this weird movement, and this is one of those internal Red Hat interesting conflicts because we just bought Innovance. We're a French OpenStack integrator, and one of their favorite things to do, which kind of drives Sage nuts, is they'll take the true Swift implementation and run it on top of Rados. So they cut out RGW and all that. And it kind of drives the Swift community nuts too. I think that there are reasons that people want Swift and there are reasons that people want Ceph. And so the use cases where people want true Swift on Ceph, I haven't really seen that. And I think the Swift community has been pretty vocal about that, not liking that, because one thing I didn't get into with this is the synchronicity of our data model. And the huge selling thing about Swift is asynchronous replication. Asynchronous replication. So you just spew data and we'll take care of it. At some point, you hope the data is going to be consistent, maybe. You think? Ceph is strongly consistent. Like we don't even, you go to write a piece of data to one of these OSDs, it gets to the primary, it gets to one of the backups. If it didn't get to the second backup yet, you're not getting an add on it right. We won't tell you that it wrote until we have satisfied your replication goals.
That's not configurable.
It is configurable.
That is configurable. The number of copies. And you can say.
You also did mention about the synchronicity. It also kind of influences your rack design as well, because you're a lot of network coming out of each OSD to another. It's got to go. You know, you've got one pipe coming in, you've got two more pipes going out, basically. So you've got some fan out networking going on. So you need to be aware of that when you design
your cluster. The hardware design of your
Yep.
cluster.
So just to clarify, the number of copies is configurable, but you can't get rid of the ACK.
You can tell it that
Minimum number of replicas.
yeah, so you can set it as, okay, fine, when you hit the first write, tell them, go ahead and send the ACK, and it'll still replicate.
Those replication policies with that in a whole like level.
Almost everything is configurable at
And like so within a RAID cluster you can have a bunch of
Yep.
or stuff.
the same, and that's the erasure coding, the replication, all of that is set at pool level. So you can say, I want 3 copies on this pool, I want erasure coding on this pool. On this pool, I want you to act the write as soon as it goes to the primary, and you set up all those rules yourself. And the big one, the big use case within OpenStack is Cinder, obviously for block devices. So we've got fairly integrated abilities between RBD and Cinder. There are some improvements that we'd like to see, especially with the interactions between these 3, Cinder, Glance, and Nova. It still does kind of some stupid stuff because let's say I have an image, an RBD image it's in RBD and Glance, it's in RBD and Cinder, and then I'm trying to pull it both ways. Well, I pull it back into local storage and I have to spit it back out. It's kludgy. So what we want to do is implement proper snapshotting. We're using ephemeral disks. So right now, we finally got cloning for ephemeral disks in Juno. That was a fight. It was actually supposed to go on Icehouse. There's this whole drama on Garrett and people pulling patches back, and we got it approved, and then he pulled it out right before Icehouse went out, and that was not fun. And we made a lot of phone calls and emails and IRC rants, and everybody said, "Oh, sorry," and then we'll get you in Juno though. Great. And then 6 months later, here we are. So it's finally coming out, so you can do cloning and RBD back from this. But what we really want to do is do the proper snapshotting, which is what I talked about. Is right here. If I've got an image that's kept in Node, why do I have to pull it back local and then make a copy to send it to Cinder to push it back into RBD when they're both in here? And RBD does all of that snapshotting, like we talked about, internal to it. So why can't I just point to it and say, that's a copy on write clone. Here, who cares? Who uses it? Go ahead. Cinder, Novo, whatever.
You need the copy on write clone JavaScript.
I wish I could. He's the RBD developer, the lead developer of RBD. And so these are 2 of our other goals is volume migration. So if you want to move from something else, say you've got an LVM backend to a Ceph backend, we should make that a lot easier than it is today. It's kind of a pain in the butt. And also, if you, for some reason, you decide you don't want to use Ceph RBD as your backend anymore, and you want to migrate to something else, we should just make that a lot easier as an OpenStack community. That's the way we force people to do that really locks them into things, and that's just not right. So we're going to put some effort into that in the next release, and we're hoping to get more people in the community involved in that as well. And then improve backup to Cinder. I mean, we have that capability in RBD. It's not integrated well with over a glance, but you know, just standard backup stuff, differential backups. How long do you want to keep it? How often do you want full backup? Just we should be able to do all that stuff. Okay, now the future roadmap. So, question was, what is H? Well, there you go. Hammer. Hammer is H release. So we're finishing up Giant right now. The big features in that are the open sourcing of Calamari, which again, even though it's kind of starting to be its own project, I included it here. We really had a lot of requests on this, but people were just not happy with fast CGI. So we pulled in Nginx, and we now enable that in Giant. So that will be an alternative front end that you can have for RGW. If you're noticing a trend here, it's, hey, take what you want. That's our mantra. Is we'll give you this, we'll give you that. You choose what works best for your implementation. People Some people may still be happy with fast CGI, and that'll still be there. It's not like we're deprecating it. It's just we heard lots of requests from people that said, I'm not really happy with fast CGI, I really like Nginx, so we implemented Nginx. And notice a consistent thing around here at the bottom. Is for the past 2 years that I've been with Inktank, we have been just throwing features at this thing. I mean, crazy amount of code growth. And the one thing we haven't done is really stopped, caught our breath. Let's look what we've really done to the performance by all these new Gucci features. And let's look at the things that we need to be doing better. Let's find areas of the code that are bottlenecks, and as hard as it may be, let's rip them apart, let's optimize it, let's run it through performance testing, and then let's re-release it. So for the next, at least, I mean, Giant, the next 2 releases, at a minimum, this is probably it for some, in some aspects, going to continue forever, but it's been my emphasis to the team that for at least these 3 releases, we need to be banging on this. And if there are areas of the code that were known bottlenecks, we need to rip them out and fix them, because we need to continue to improve the performance of the underlying object store, because as you saw with that, it's a pyramid that everything built on top of it. So if we've got bottlenecks down here at the object storage level, that just propagates all the way up. Now what makes it interesting is that we may have bottlenecks, say, at the RBD level that hide things from the object storage level. So we may be having problems down here that we can't even see because people are blocked by something in the RBD code. So we need to make that as performant as we can. And then that may reveal further performance improvements that need to be made at the underlying Windows level. So that's what we're hoping to do for the next 3 releases. Object versioning and object expiration are the 2 big things that people point at for the gateway when they say, hey, here are the deltas when I go through my checkbox of Swift can do this, RTW can do this. You don't have those. So those are the 2 big things that we feel like we need to implement over the next 6 months.
So the performance improvements just made me think. So should we be exercising Toothology against this all the time? Should we be exercising Toothology against our own clusters? What?
That would be awesome. And actually, you can. Speaking of new open source projects, we are contemplating rolling out Toothology really with its own community and everything, and creating a true open source project. It kind of is.
And you might want to.
Toothology is our automated test suite, which is crazy configurable. I mean, you can tell it, basically, you can point it at a group of machines and say, okay, here's your available pool. Here are the tests I want to run. And it'll go out and say, okay, I need these machines. It'll queue up. It'll grab those. It'll go ahead and install Ceph for you. And it'll say, okay, I want these to be monitors. I want these to be OSDs. I want 3 monitors. I want 20 OSDs. And then it'll go off and run those tests. And, oh, by the way, you could say, I want these to all run on RHEL 7, or I want them all run on Ubuntu 14.04, or I want some of them run on Wheezy, and I want some of them run on Precise, and it'll go off and do that. And then it spits out the results, sends an email out to the group, and then it also has this pretty cool front end we implemented called Pulpito, which is Spanish for big octopus. And
Toothology is the study of octopus.
Yeah. And so Toothology spits the data into Pulpito, and then you can see, okay, you can, through that web front end, gauge over time, how is this test performing? Well, it was fine for 3 weeks, and then yesterday it crapped out. Oh, what happened? Who committed something there? And so the test suite is really fabulous. The automated testing is very powerful. And we've got 2 partners that are standing up their own Toothology instances. And we're looking for more people all the time to run Toothology, run their testing. That won't give us as much of the performance data as we need, but it'll help us do more of the unit system integration. The more instances of Toothology run on the more various types of hardware will give us better data too. Yeah, please, everyone run Toothology. Then, as I alluded to earlier, we don't really have good disaster recovery for RBD. We've got snapshots, which is better than nothing. You can send snapshots across the wires and kind of replicate your RBD that way. But it's not true disaster recovery here. So that's what we hope to, we're really trying to pull it into where we might get a tech preview. Josh would hate me for saying this, but I'm trying to get a tech preview in Hammer. I don't think it's going to happen. We're really shooting to have it done by iRelease. And then when they get done, RBDDF should be done.
You mentioned that you were hesitant about file systems, so you got that fast check or some type of data scrubbing. Is that in the roadmap anywhere?
I don't put Cephfest anywhere on the roadmap.
It was going to be released in Giant, was last I heard.
It's
I heard that.
I can tell you what Sage wants.
I heard that in E-time frame though.
Sage wants that forward scrubbing type check in Hammer. If that makes it somewhere in this time, and just to give you an idea of time frame, so this is now Giant. Hammer is January-ish, and so this would be May-ish. So wearing my community hat, not as a spokesman for Red Hat guaranteeing product availability, I would say that you could probably be looking for Cephfest sometime in the summer. Okay, I've given my spiel. I've walked you through what we hope to do in the future. So if you got excited, what are some things that you can do? Well, I got to add stand up my own toothology. Thank you. I got to so get started with Ceph. Go to the docs. That's the one thing we get lots of. That's an easy way to give back to an open source community. Is like anybody, the docs. Because we're making changes all the time, we're flying with our hair on fire, and the last thing you're doing, if you're a developer, is want to write documentation, right? Because it's intuitively obvious, just go look at the code if you want to know how it works. So that's where we can really use help. If you say, hey, I want to stand up my own subcluster, hey, what the hell, this doesn't do what it's supposed to do, or I have to do --X instead of -X. It's open source. The documents are. You can submit a pull request to GitHub, and we'll happily accept it. You can see that easy ways to get your own Ceph cluster up and running, Ceph deploy. You can even throw one up on AWS. And then get on IRC. Like I said, that's where we are. Somebody in the community is in there 24/7. There's like 300 some odd people. It's great. Get on #Ceph, again, on oftc.net, on Freedom. And Ceph Devel is the one specifically for developers. So #Ceph, we had so many people that we had to split up the IRC channels because we had people that were trying to ask questions about, hey, should my pull request look like this? And I've got this question about my code. And Sage is trying to talk to them at the same time that we've got somebody in France saying, hey, my cluster's falling over, and here's the error message I see. He dumps it into the IRC, and they're like, ah. So we split up the Ceph and Ceph Devel, and they're both still strong channels, so it's been really exciting.
One other one you might want to add is you can actually do DevStack with Ceph as well now. So if you Google DevStack Ceph, you'll find a link from your friends at EagleBoss, also at Red Hat now.
You could not do that before
July 20th or something.
So very thankful for that. That's all I had. Here's me. We'll put these charts out. This has little hyperlinks to Venus. If you want to connect with me, just don't call too late at night. Although my wife has been good about making sure that I don't leave my cell phone upstairs with me. It's a hard boundary. I challenge you all to try. Leaving your cell phone downstairs, it's just such a novel concept. Don't put it next to your bed.
What do you use for an alarm clock?
Brought to you by the people at Jawbone. So please, honestly, if you have a question about Ceph, if you have a question about my presentation, give me a call. Twitter, email, this links to my LinkedIn profile.
Going back to the Swift stuff thing, so you're saying that people are actually running Swift directly on a block device or directly to native Swift or native.
The Enovance people, and I've deliberately kept ignorant about this because it drives Sage crazy, are running the Swift front end on top of Rados cluster. So no gateway.
No RBD.
I guess
No
I'm trying to
RBD.
understand why that's so unliked. I mean, what's the problem?
I think it's the idea that what you're using Swift for is typically for different use cases, or the true Swift implementation of you're looking for eventual consistency as opposed to the strict consistency that you get with us. So if you're willing to put up with, if you want to make Swift calls, Sage would say, you're not going to get the performance that you'd get if you use RGW. Why don't you just make Swift calls to the gateway? If there's a subset of the API that we don't support that you think is important, then tell us and we'll implement it. Because this is built wired into Librados, so this is where you get the best performance, and we support the API. It's just, like I said, some of the Swift functionality, they kind of pretend is in the API. The biggest one, like we noticed recently, is /info. If you want to go out and see what's available on your cluster, we thought, oh, people have said, hey, you don't have /info in the gateway. Oh, that's a great idea, let's try it. It's not part of the API. It's part of the underlying Swift functionality, so there's nothing I can do. Other than encourage anyone, if you're an active member of the Swift community, encourage them to push stuff up into the API and really expose it. But there again, then SwiftStack, company behind Swift, is completely disincentivized to do that. Because the last thing that they want to do is turn Swift just into this box. They don't want to turn Swift just into an API that anybody can call to, because then that takes away their value proposition, because then anybody can do it.
So you're saying that you get better performance by going to the gateway because you don't have to wait for the replication, essentially.
I don't think that's what he's saying.
No, I'm saying you get better performance because it's tied into Librados, whereas with the
Well, if
implementation,
you're going directly Swift to Rados, would you be going to Rados?
there's some kludgy stuff that, like I said, I've deliberately kept myself away.
It's not as clean as it sounds.
So I work for Time Warner Cable. Most of you guys know that. And we actually implemented both Ceph and Swift. We're one of those customers. And we have both on contract for support. May or may not be public, but it is now. Specifically because we needed geographical replication. That's why we have a global Swift, but we have a regional Ceph. And we have multiple regional Cephs as a result. And that solves all of our problems. And so we're happy to support both of those storage infrastructures because they solve our bigger cloud problem. That's what met our needs and in the time that we needed them met. It wasn't performance. It wasn't really the speed of Swift returning. It was literally what's the best solution for our geographically dispersed organization.
One thing I've been negligent mentioning, maybe it's because it became such a part of our story around the origins of Ceph that I tend to not talk about it a lot, but if you look across here, one of the attractions to Ceph is the unified storage. And that's why I think it's gotten a lot of traction in OpenStack. It's, okay, singles, I don't have to stand up to. I can do my object via the gateway. I can do my block via RBD. I can use a single technology. I don't have to stand up to. If I go with a Swift implementation,
There's a whole other replication.
I get my object stuff, and then what do I do for block?
It actually gets better once StephFS is fully baked, because then you can kick out any kind of NFS that you have to have in there today.
And we're part of Project Manila for OpenStack, so the goal is for that. Yeah. I mean, it just became a full-fledged project, so maybe it'll be all grown up.
It's still incubator. It's not.
I think
It's in incubation.
it's an incubation, but I think it's
Oh, it gets promoted and field.
And it's just out of date.
That's what I thought.
3 weeks.
It's a long way.
So I think the goal is, by the time this is all grown up, that vanilla will be too. That's kind of our internal goal.
That makes sense timing-wise.
What kind of things have you done with the newer, like 8 terabyte drives, like the shingled magnetic
Ooh,
board?
actually, those are really cool. We haven't played with them much. I mean, I've only we have not played with the shingle drives. Where we've actually played more is with. Let's see how much of this I can say. There are 2 vendors that have
I know
Ethernet drives.
so you go ahead and talk about.
There's one in the room here. There's one that's not. Unless there's anyone in here with a company that starts with an H that I don't know about.
They're probably here too. Or they have been here before.
So we are working closely with both those companies because this Sage's dream way back in the day when he spawned the Ceph was that you can have a piece of software running on a physical drive. And that's what these Ethernet connected drives from those 2 companies allow you to do, is to have this object storage daemon right here that's running literally on the drive.
It's part of the controller, but right.
On chip. So you can't get much lower latency than that. But I'd like to put a shield drives.
I'd be curious about upgrading a cluster you built, like 3 terabyte, 7200 RPM drives, just 8 terabyte drives.
I think the biggest, well, my slide was crap with the line drawings. The biggest thing we have to work with any type of migration is ensuring that you throttle that back end stuff so we're not killing your.
Is that max requests? Max backfills?
Max backfills. Any other questions? Thanks for your time. And if you want a Ceph sticker, I mean, without any of the Red Hat propaganda, just a Ceph sticker, please, you have my information on there. Twitter me, email me, whatever, and I'll send you one. I'll send you a whole stack of them.
If you send me an envelope, I'll make sure they're available at the next meetup as well.
But please take the fun Red Hat swag back there. Don't want to denigrate it too much, but it is plastered with Gluster paraphernalia around it, including Red Hat Storage Server 3, which is a Gluster product, in case you weren't wondering.
And I didn't ask you this ahead of time, Ian. There's one other thing that we do. So on the Meetup page, Jamie posted a link to some discount training from Red Hat. I don't know what it covers. I didn't actually read the offer, but it's out there. If you need more information, let me know. I can pass it on to you. More important is Red Hat hiring. That's one of the things we talk about at every meetup. We always ask the sponsor if they're hiring.
I am hiring. I've got, and that's the beauty of my team is you can live up here, you can live down wherever, you know, you could
Nobody
live
lives
in
near you
Lisbon.
that works for you, do they?
I have a guy that lives in Boulder is the closest
Oh,
one.
okay.
Closest one. So.
So Red Hat's hiring, Inktank's hiring. Okay. I'm sure if you talk to anybody else in this room, I know I'm supposed to say that I'm hiring. Talk to Matt Fisher, though, if you want to know about our company. If other people want to stand up and say that they're hiring, I encourage you to stand up. I know HP is hiring. Very, very happy. They're not here. Not here now. They're here today. They're not here now.
HP's closed their reps.
No, HP didn't.
HP
Yeah,
did not.
HP Cloud, you got.
HP Cloud is recruiting so hard you can't imagine. So
which part of HP is that? I'm so confused.
Yeah, but that's true.
Is that HP Enterprise?
Is
that HP?
It's mostly HP. Let's see.
And then for the next meetup, because what people are interested in.
Oh, so Randy has graciously offered to be, at my request, the backup coordinator for this meetup. So if you haven't met Randy, he's just joined Cable Labs. He's recently of HP.
and recently, before that, from HP Cloud long ago. So if you don't know Randy, make sure you introduce yourself to him. And he's offered to actually